Let's go to page 292. This is lesson 6-8. The objective of this lesson is to add, subtract, multiply, and divide complex numbers. Now, the complex number is in this form of a plus bi. So a is a real part, b is an imaginary part. So here are some examples. So here's your real part, imaginary part. So this is a complex number. Again, complex number comprised of the real part and the imaginary part. But in some cases, for example, like you can have 0 on imaginary part, right? Now, you also break the complex number, again, break down to two parts. Now, if b equal to 0, means you don't have the imaginary part, so you just have the a. So a is a real part. So yeah, this is an example of the real number, okay? And instead of going this, I'm going to go straight down to here. So if a equal to 0, then you're going to get the pure imaginary. See that? So again, if a equal to 0, means you only have the imaginary part. So this is called a pure imaginary number. Okay. Now, imaginary number itself, it can have or not have the real part. Okay. So like this over here, you have the real part. But this one don't have a real part. Okay. So these two are very close. Okay. But again, anyway, complex number comprised of the real number and the pure imaginary number. Okay, so imaginary number and the pure imaginary number and real number together. Okay, this is part of the real number, complex number. And the real number can be broken into two kinds. The rational number, the one that can break down nicely, like into a fraction, and the other part is irrational number, which cannot be put into a fraction. So this is kind of how the numbers are kind of part of the subset of the complex numbers. Okay. So again, complex number have the real part and imaginary part. Okay, let's go to page 293. This is the equality of the complex number. It says a plus bi is equal to c plus di if and only if a equal to c and b equal to d. So again, two complex numbers are equal only if the real parts are equal to each other and imaginary parts are equal to each other. That's the only time that it's equal to each other. Okay? And next one is a sum. So when you're adding the complex numbers, you got a plus bi plus c plus di. Okay, so when you're adding complex number, you only can add the real part with the real part. Okay, so you only add the real part with the real part and imaginary part with the imaginary part. So you cannot mix the two together. Okay, so again, real part with the real part, that's the only part you can add. An imaginary part with the imaginary part. So you cannot mix the two together. Okay, you only can add same kind of numbers. And when you're multiplying, you got a plus bi times c plus di. So this one will be equal to ac minus bd plus ad plus bci. So what I'm saying is that you just use FOIL method, FOIL it out, and you combine the like terms. So that's what it's saying. Okay, so again, it's not as obvious over here, but when you're doing examples, when you're doing a problem, you just go and FOIL it out, you're going to get that. Okay, so again, you just do this, you got ac, okay, plus ad. So that's, and then you go ahead and multiply. So you're going to, di. Okay, and then so after you do this, you're going to distribute the next part. So you can just use your FOIL method. And so this would be plus bci, and then distribute. You're going to be plus bd. Okay, but remember, I times I will give you negative, right? So this becomes negative. Okay? Again, I times I give you negative. That's where the negative came from. Okay, and that's where this came from. See, AC minus BD. Okay, and plus this part over here, AD plus BC. See that? So again, so what it's saying is you're just going to FOIL it out and just combine the like terms. Combine the like terms. Okay, so that's how you get that. So again, what it's saying is that you just FOIL it out and combine the like terms. Okay, that's what this is saying. Okay, let's go over examples. Okay, example 1a, you got 3 plus 6i plus 4 minus 2i. Okay, so first let's go and drop the parentheses. Since it's addition, so we don't have to do anything to it. Okay, we can just drop the parentheses. Then let's go and combine the like terms. Remember, you only can use the same kind of numbers to add. So real number with a real number, so that's 7. Then you have imaginary number, and imaginary numbers would be plus 4i, and that's it. Okay, so you only add the same kind of numbers. Okay, 1b, you got 3 plus 6i minus 4 minus 2i. So you have to be very careful. There's a subtraction now. So when you drop the parentheses, this one you don't have to do anything. This one you have to kind of distribute. So this will give you minus 4, and it'll be plus 2i. Okay, so if you drop the parentheses, when you have negative, okay, so you have to watch out to distribute. Then after that, you can go and combine the like terms. So 3 minus 4 is negative 1, and the plus 6i plus 2i will give you plus 8i. Okay, so you only add same kind of numbers. Okay, do not mix the two different kinds of numbers. Okay, let's go to next example. Okay, example 2a, you got 3 plus 4i times 5 plus 2i. Okay, so this one I can just go and distribute. So multiply, so it'd be 15 multiply, that's plus 6i. Okay, so when you're done with the first term, you go to the next term. So this will be plus 20i multiply. So 4 times 2 is 8. I times I is negative 1, so it'll be minus 8. So you have to be careful with this, right? So don't write plus yet. Okay, so 2 times 4 is 8. Then I times I is negative. Okay, so this is the part you have to pay close attention to. Okay, then after that you can go and combine the like terms. So this will give me 7, and this one would become plus 26i. Okay, let's go to 2b. Okay, you got 3 plus 4i squared. So you need to know how to multiply the perfect squares. Okay, so this one, 3 squared will give me 9, right? And plus squared will give me plus. 4 squared will give me 16. I times I, it give me negative 1, so you have to change this into negative. Okay, so I squared is negative, so give me that. Now the middle term, again, remember when you square binomial, you're going to get a middle term. So when you multiply the middle term, you take care of the sign, so it'll be plus. And then sign, the number, 2 times 3 is 6 times 4 is 24. And then you have the variable or the letter or whatever, square roots. Okay, so that equal to that. So now you can go and combine the like terms. So this will equal to negative 7 plus 24i. Okay, 2c. Okay, you got 3 plus 4i times 3 minus 4i. So this is just the common regular multiplication. These are special products, special multiplications. So this is the perfect square, and this is the conjugate. Okay, so when you multiply by conjugate, the O and the I going to cancel out like this over here. See the O and the I get canceled out, okay, because of the conjugate. So all you have to do is multiply the matching part, the corresponding part. So 3 times 3 is 9. Plus times minus is minus. 4 times 4 is 16. I times I is negative 1. So negative 1 will make this into positive. Okay? And therefore this is equal to 25. Now, if you notice notice something over here, when you multiply, the I stays, right? So you still have I. When you distribute, you still get I, right? But over here, when you have conjugate, notice there's no more I. So that means to get rid of the I, you need to multiply the conjugate. Okay, so when you multiply the conjugate, you will get rid of the I. And that's going to be important for the following examples, okay, to simplify. So let's go to the next example. Example 3. Okay, you got 5 minus I over 2 plus 3i. Okay, so you can remember, we're not allowed to have an I in the denominator, so we have to get rid of the I. Now to get rid of the I, we cannot just multiply by I itself because there are two terms now. So when you got two terms, to simplify, you need to get two terms. So to get rid of the I, just from this example over here, remember, in order to get rid of the I, we need to have a conjugate. So when you have conjugate, the I is gone. Okay? So to get rid of I, we need to multiply by conjugate. So we need to multiply by 2 minus 3I. Okay, so again, you need to conjugate to get rid of the I. So now, if you multiply by the conjugate, you need to do the same on the top. Okay, so whatever you do on the bottom, you have to do the same on the top. Because this is equal to 1, and when you multiply by 1, you're not changing anything, right? Okay, so now let's go. You always multiply the bottom first before you multiply on the top. Because sometimes you can cancel with the top. Okay, so let's go and multiply. So this will give me a 4. 2 times 2 is a 4. Plus times minus is minus. 3 times 3 is 9. I times I is negative 1, so it becomes plus, right? And so this will equal to 13. Again, I always like to simplify the bottom first. And there's nothing to cancel with the 13, so we can just go and FOIL it out. So FOIL methods would be 5 times 2 is 10. So I use this times that. Then use this times that would be minus 15i. Okay, so I'm done with this one, so I go to the next one. So this times that will give me minus 2i. This times this, and I have to be careful now. Negative times negative is positive, so take out the sign. The number is 1 times 3 will be 3, and I times I is negative. So now this will become negative. Okay? So again, when you multiply, you always do the sign, the number, then the alphabet. Okay? So sign, negative times negative is positive. Number, when you don't see a number, is 1. So 1 times 3 is 3, and I times I is negative. Okay, so now we can go and combine the like terms. So 10 minus 3 give me 7, and this one would be minus 17i. Okay. And normally you want to put in a plus bi form, so you want to separate the real part from the imaginary part. So you want to go and write 7 over 13, that's the real part, minus 17 over 13i. And make sure I is kind of big out here. So that's your form of a plus bi form. So whenever you have a complex number, you always want to write in this form. Okay, so remember that. You want to write in this form. So the real part and the imaginary part. Okay, let's go to example 4. Okay, you have 3 minus I, and you want to find a reciprocal. Reciprocal means you flip it over. So reciprocal of that is 1 over 3 minus I. Okay, so now you have the I in the denominator, so you need to simplify that. So you can to simplify, to get rid of the I with the two terms, you have to multiply by conjugate. So you need to multiply by 3 plus I. So when you multiply by 3 plus I on the bottom, you need to do the same on the top. Okay, so again, let's always do the bottom first. So 3 times 3 is 9. Negative times positive is negative. I times I is negative 1, so this becomes plus 1. Okay? And on the top, there's nothing to cancel because that's only 1 over here. So you can just go and distribute. So you get 3 plus I. Okay, so now you can simplify. So it'd be 3 plus I over 10. So this is equal to 3 over 10 plus 1 over 10I. And that's it. So the key point to remember is you have to multiply by conjugate when you have two terms. Okay, multiply by conjugate, multiply by conjugate to get rid of the I. Okay, and that's how you simplify it.